Hello everyone, so as you can see the board is done, and in this video I want to go over the design of the thing, I guess. There were obviously a bunch of mistakes. I mean, I could have caught them if I prototyped a little bit more, how would I say it, slowly and thoroughly, but who has time for that, right? So the original idea was that I will make one board that will be like a prototype and I will use it for my home server, but this does not have Ethernet, so I'm not sure about that. Maybe, possibly, but I need to do a bunch of prototyping still because I need to make case, I need to make a keyboard, I need to make a display, and I need to connect it all together and test that it will work before I will make final of these, because the total number of boards that will be produced probably ever is 2. Not 1, not 3, definitely not 4, but 2. 2 is the number. So I can actually power this board on at least. I mean, this is a little bit convoluted right now. I need to connect to power management circuit because there is no power button on this board. So next I need to connect battery. I'm using this teeny tiny battery, and the funny thing is that it is able to run this for like 10 minutes or so. So that's funny. But it's pretty much discharged, so I will connect it to charger. Then basically what I will do is I will use this kind of sort of terminal in Arduino IDE, and now it is on. Let me try to connect this to HDMI. And it runs. This is interesting, I did not have these artifacts on the screen before. Maybe there's some dirt in the connector. I mean, there was a lot of cleaning done on this board anyway. So normally what I would do is, fuck's sake, I would connect to this over SSH because, like, obviously, and then I shut it down from here. Okay, so I guess I can do a little bit of, oh my god, this is super ugly, but what can you do, I guess. So in the power management there have been no significant changes. It worked out of the box, other than there was incorrect voltage on the output, which I found out very quickly. I have made mistake on the audio. I have swapped the inverting and non-inverting inputs, but still it's shit. This connector is like not working correctly. I have swapped data lines on this USB port, and this trick of routing USB 2 to the hub and then back to USB 3 port did not work either. So this port is only USB 2 now, I guess. Anyway, everything else seems to be fine. These two connectors, holy shit, these were not easy to solder. Like, if you look here, this is 0805 or capacitor, and look how tiny this connector is. Anyway, but it was doable. I had a lot of trouble with PCIe. I mean, everything worked correctly. There are no changes. It's just this connector is surprisingly difficult to solder. So that's that. Okay, so the design. I guess I will be switching between board view and schematic view because I guess it's best this way anyway. So I can do block overview on the board, like this is power management. It is fairly confined to single point, and I mean, this doesn't make too much sense because this is get off. This is just connectors. This one is like a bit outlier, but I could have put it here, but it's fine to be here. This is just PCI Express with the buck converter and some clock generator here. this is there are pull-ups for I2C and sound interface. Obviously there is a bus to the quote-unquote card, which is only this connector, and here is the bus. And this is USB hub, also fairly confined. This is I guess power switching for the USB. It is limiting power to 2 amps, and there is random connector to keyboard, even though this connector is connected to I2C bus on power management, but whatever. So I guess you can say that board is fairly chaotic, but anyway, let's start where the things start. So this is power management. Obviously the power comes from here, or the battery, but let's not think about it, I guess, right now. This is chip for USB PD negotiation. From there the power goes to this FET, and when this chip thinks the power is good, it turns on this FET, or closes it basically. So power then goes to this chip, which is charger, and from there it goes to the battery. I mean, the thing is a bit complicated because this regulator is powered on from battery or from outside source basically, but what's my point? I don't know. Well, anyway, so battery is charging, there is power measurement set up for it. It is done by this chip. This is like 16 bits chip that measures power over I2C, which is nice. And this is a recent addition because I realized that I need to isolate the boost converter, which is here, from the battery. Otherwise the Pi may have trouble turning on. I have tested it with some random battery and it turned on and off when I basically enabled boost converter and disabled it, but I think that when the battery is if the battery is above some voltage, it has trouble. You may say that I have made a bit of a mistake because these 3 chips can be combined into one. There is this chip that has apparently it supports USB PD, but I still don't quite trust it. Like this is input sources. Is there any USB PD mentioned here? No. In the datasheet it is like mentioned that it supports USB PD source, but I don't think there is nothing about negotiation in the datasheet. The PD is mentioned just very vaguely. It is the same thing as I had trouble with this charger. Like this has CC and data for USB communication. I thought that it supports USB PD because it supports like 16 volts input. I thought that it supports USB PD, but nope, it supports only like USB-BC something and something. So the thing is, as I said, let's select this thing, and there's not much space used by components. Like the single chip would be cheaper, obviously, but like, I mean, it would be a little bit bigger than this chip, so hopefully I will be able to squeeze it in this space, because like there is not much space it can go in. Like there is this inductor that cannot really move anywhere too much. There is this chip, and if the number of passives are higher than this, I would have trouble putting it here. Like it could move battery terminals, I guess, somewhere else, but anyway. And the point is that, as I said, this board will have 2 pieces made, and I already have these components and I already have this design. It works, I don't need to change it. So if I was you, I would definitely test the chip, because I think it supports also like 1 to 4S battery packs, so that is very nice that it does that. This is the main controller for the power management stuff, I guess. It doesn't do too much stuff. it controls this transistor basically. It controls this boost converter and it communicates with all the chips with I2C bus. So that is pretty much it. I was thinking that maybe it would be nice if this communicated also with the LCD driver board, because there will be buttons on the keyboard to probably to change the display brightness, and the keyboard is directly connected to this chip, well, to this I2C bus. And so I was thinking that it would be easier if I delegate the low-level stuff to this chip, because it can be programmed easily. I am not sure how well the software will work on the Raspberry Pi side, but my point is, I guess, that I don't want to write drivers. But anyway, finally there is this chip, which is a recent addition, because the I2C bus was connected directly to Raspberry Pi, but then during testing I have realized that it doesn't work when the Pi module is in there, because when the Pi is shut down, it pulls down the I2C bus, and basically this cannot communicate with anything. So, and I forgot one thing, that there is this 3.3 volt input. This is from Raspberry Pi internal 3.3 volt regulator. This goes to this chip. It can cause interrupt if it falls down, which means that the Raspberry Pi is turned off, which in turn disables boost converter, because it does not need to be running. So obviously there is a bunch of stuff. This is probably only needed for the keyboard connector. Yeah, it is only here. I should move this connector out of this sheet, but anyway. So obviously when the system is powered off, I need this 3.3 volt to be distributed to the keyboard to wake system up, because nothing else has power pretty much. So here there are just a bunch of connectors and this current limit for the USB port. This is all pretty much copied from the original development board or I/O board, apart from this display connector, because I was like, well, okay, I can limit the amount of connections by providing actually 5 volts and 3.3 volts. This would be probably some low level or low powered logic. This could be for driving backlight, and I2C I think was connected to this connector, but this means that this connector is not standard, which I'm not sure if there are standard driver boards for these displays. From my quick research, there are not. This is also a little bit fucked up. This is VBus is going from the hub and the board is too, but this is because the hub is also powering the other USB ports. The hub is powered from Raspberry Pi internal voltage regulator, and there are two internal USB buses. One is going to keyboard connector, I guess, hence why the connector is here. The other one goes to the card, which is here. As I said, I don't want to write drivers, so that's why the keyboard has USB connection. This is also pretty much copied from the I/O board. And finally there is this sound interface. I have copied this schematic from some guy's website. I need to investigate if this change to this connector would make it work, or I need to move this track here. But I'm quite unsure if this is correct. He has this connected with some kind of resistor for some reason. Well, actually some voltage divider. The emphasis can be probably shorted to ground. Yeah, I can remove some components. That would be nice. And otherwise this should work, unless I screwed up the connections here. I need to test this definitely. Anyway, that's the boring stuff, I guess. Oh shit! Now I have noticed. This has Raspberry header. Fucking hell! They now own copyright of my work. Shit. Anyway. Yeah, that's boring stuff. Let's check the board because I think this is wild ass. I don't know where to start. Well, first of all, there is too many vias. Last time I counted it was like 34 if I don't count these, because these are not real vias. These are just to have holes to connect wires to, basically. There's probably a better way to do this, but anyway. Yeah, obviously the tracks here are tiny, because, I mean, not that tiny, but this is probably the smallest tracks here are 0.2 millimeters, so this is doable even on laser printers, I guess, even though good luck. Other than that, there's, as I said, there's nothing on the bottom layer pretty much. Like, yeah, there's quite a bit, but not too much. I had to squish this I2C isolator to next to the board. I had a little bit of space here. Okay, let's go over, I guess, thermals, because I did not check yet the high power charging, which I need to do, but this chip is able to charge battery by 5 amps. So the power has to be dissipated somewhere. I'm not sure how much power does this produce when it's charging at 5 amps, but it is possible that I will have to limit this artificially, even though I will be very unhappy if I had to do that. Also, the high current flows from here to this pin, and this is the only pin that is here, so yeah, I had to do some tricks. This ground situation is not great. The connection to inductor is done via copper zones. This is the best I could do probably here. The tracks are a little bit wider than the pins on the bottom of the chip. I'm not sure if this helps very much, but they diverge as soon as possible and as much as possible, so that maybe helps. I could have moved this a little bit here so it has a bit more copper area as soon as possible. I will probably do that, and so yeah, this chip can probably get quite warm. Next thing that draws a lot of power is this chip. It has recommended some vias here, so I've added some. Note that these vias are 0.8 millimeters and the wall thickness is 0.1 millimeters, so one via is like maybe 5 or 10 small vias here. Even though I have heard that small vias are better for thermals, but the high power connections on these chips are a little bit better. Like, I'm not sure why I have done this, but it works. Like, this chip is cool. This chip is very cool. I did not try to draw too much power from it yet. Well, I'm not sure how much power can Pi consume, but these peripherals can draw quite a bit of power. There's 2 amps reserved for these 3 USB ports. There's, I think, 1 amp reserved for the buck converter, and another 2 amps for this USB port, and this little tiny track is providing power to HDMI connector, which does not need much power. So that's basically all the power sinks here, I guess, at least from 5V rail. So it results in this nice snake that goes around the board and almost loops back to the USB connector. So yeah, and also to the display. I forgot the display. But idea with this vias is that you basically solder wire through it and run it through the hinge to the display if I'm using HDMI connectors. The HDMI connectors are split because of routing, I guess, otherwise I wouldn't be able to do it. But, well, also you cannot really buy these connectors much wider than this. Speaking of snaking, is it this one? Oh hell yeah! This is 3.3 volt rail from the pi voltage regulator, and the amount of snaking here is basically partially because of ground, like at least here. Like normally you would run this track from here to here directly, but then where the ground for this chip would come from? Well, nowhere. You could add via, but you know, vias are overrated. That said, if you consider that only ground vias are pretty much here, well, there's actually one here. And that is actually kinda sorta unnecessary, so it. I mean, because there is this connector. Well, this is our via basically, and there are a lot of vias, quote unquote, like this. Like there would be no way this has ground or this port has ground if this was not here. So yeah. And there is really some sketchy stuff. For example, these capacitors, these are for smoothing. The only place this get ground is from this tiny sliver of ground plane, which goes from here and from here. Most SSDs are flat on the bottom, so I could move these capacitors under here, but this is also low profile connector, so I have opted to not do that. There are a few jump resistors like here. This is basically to avoid two vias. Like, it's better to solder one component than to drill two holes, then put two vias in, then solder them. So there are not many of them actually. So there's one to route I2C signal. There's another one to route another I2C signal. This one is for PCIe, some simple signal. Oh, and another one. This is HDMI CEC, also not very high frequency signal. And another one for I2C. And finally, this is a long one, and this is not really 0 ohm. I have used the same that I used for measuring battery power. Yeah, so this is the same resistor as this one. Yeah, so the ground. So I am amazed that everything here has kinda sorta proper ground, apart from this one place that is like highlighted by a rat's nest. Well, highlight, not really, but so this thing is not grounded. If I add via here, it would have proper ground. They say that it is mandatory to connect all ground pins on these connectors to ground, but I say nah. Also tangentially related, I'm not removing islands in ground plane on purpose, and this is solely for etching, because I want to have as consistent etch time as possible. So like, this is less copper to etch than all this thing basically, and so I want to spend as little time etching as possible, and that's why the ground is pretty much everywhere, or at least the copper, even if it's island. It's probably unnecessary, but it is also fine. Like, it's not really ugly, you cannot see anything like this. Sometimes it's a little bit confusing, because like you are soldering, say, here, and is this track or not? You are not sure basically, but I think it's also a good idea to talk about high-speed stuff. So for example, this HDMI connector is implemented like properly, because the impedance between these tracks are like what is prescribed. I don't know if it's 100 or 90 ohms, but somewhere I have to break rules a little bit. So this is also quite good. The fact that there is missing ground here is not great. Also here, because there is some crosstalk probably. The USB has different impedance, so that's why tracks are quite thick, and again, no isolation because I couldn't physically fit it there. And finally, the PCI Express. Yeah, it works. The alternative would be to basically put a bunch of vias here that I don't really have space for. These vias are so huge that they would probably screw with impedance much more than this. And also this USB 3 signals, they have to be, yeah, I cannot draw this any differently. The impedance in this section is basically improper, and then it continues. It has at least skew correction, and finally goes to the connector. USB 2 is tough as hell. Like, you would have to be absolutely ridiculously stupid and retarded to wire it incorrectly, such that it doesn't work. I did not have any experience with like these high-speed signals, but now I know that, for example, this is acceptable as a least resort, so I could have been probably more careless with other high-speed stuff here. Oh, and finally there is this display connector. This is also, I would say, implemented properly because, well, apart from missing isolation between these pins, but this is pretty much ground. Like, hot plug is some pull-up basically, so the risk of crosstalk between I squared C and this pin is quite low, and there is ground between these tracks. I've routed it manually because it's easy, I guess. I had to cross this track here. This USB 3 line, I mean, yeah, this is garbage. This is absolute garbage, and I cannot test it really still because I have wired this incorrectly, but I have no doubts that it will work correctly. Also, I did not do any bandwidth measurements on this, so it could be that I'm losing few megabits per second